Hi guys, welcome to week 2 of medical math. For those of you guys who are in my Monday morning class, this is chapter 2 for you guys. If you're in my Tuesday morning class, this is chapter 1 for those of you guys that want to follow along in the book. This is everyone's most dreaded topic. Fractions is, for some reason, just the most hated subject in this book, but I promise you today we will get through this, and hopefully by the end of class today you guys will, if you don't enjoy fractions, at least you will perhaps like them a little bit more than you did at the beginning. Today we are going to learn how to add, subtract, multiply, and divide our fractions. There are some rules to follow along with for each operation, and I will make sure that I get those rules written down for you guys so you guys can follow along and take notes along with me as we go through this chapter today. As we get started in these, though, I want to first introduce fractions. Before we even get into the operations themselves, I want to introduce fractions to you and start by kind of just showing you what fractions look like, some things that we're going to do throughout the class with our fractions as well. For those of you guys who are used to seeing a fraction, you guys may recall that a fraction is simply just one number written on top of another. So as I have up here on the screen, 3 over 4 represents the fraction that we commonly know as 3/4. 3/4 represents all fractions really represent a part to total relationship. So the number on top is our part, and the number on the bottom is our total. Every once in a while, you'll hear me throughout this class today refer to that top number as what's called the numerator and the bottom number as the denominator. I'm not going to quiz you guys on that. I think you all will have that memorized by the time we get to the end of class anyway, but for those of you guys who aren't familiar with that, that's what that is. Numerator on top, denominator on the bottom. I just want you guys to know what that is. When I say things like we need to have a common denominator, you know I'm talking about the bottom number. Anyway, but that's what a fraction shows us. So if I have the fraction 3/4, that represents 3 out of 4 something. Whether it be if there were 3 apples out of all pieces of fruit in the fruit bowl, maybe the other one was a banana, then 3/4 of the fruit bowl are apples. Or perhaps maybe not in this particular class, but maybe in a class for every 4 students, maybe 3 of them are female. That would mean that 3/4 of that class are female. Or what have you. Again, that's just what that particular fraction represents. Couple things we can do with fractions. A lot of times, I think the best way to represent fractions, in my opinion, is to draw pizzas. Because we can easily see, like for instance, if I were to take a pizza, let me get a marker here. If I were to draw a pizza and cut it into 2 pieces, and let's say I ate one of those 2 pieces, then as a fraction, I had 1 out of 2 slices of pizza. And that fraction that you guys see written down there, you guys are probably used to seeing this. We know that that represents 1/2. I had 1/2 of that pizza. Because we say 1/2 because it represents 1 out of 2 of something. So in the case where we have this pizza here, we had 1 out of the 2 slices. But we know that when we order pizzas from, say, Papa John's or Domino's or wherever, they don't come in just 2 slices. We know that. If you order pizzas as much as I do, you know that they come in 8 slices. So let's say we have the same size pizza, and let's instead cut it into 8 slices. Instead, we can see that obviously my artistic ability is not fantastic, but you guys get the idea. It's supposed to show the same exact size pizza, but this time we've cut it into a different number of parts. So this pizza represents we have a total of 8 parts. If I want to eat half of this pizza, just like I did on the one over there on the left, half of the pizza would have to be 4 slices. So in this case, the fraction of showing what I ate of this pizza is 4 out of 8. But what the reason why I'm showing this to you guys is you can see in both cases, it represents the exact same amount of pizza. Over here, 1 out of 2 slices looks like this, and over here, 4 out of 8 slices is the exact same amount. In both scenarios, I ate the same exact amount of pizza. This is what's called equivalent fractions. This is going to help us tremendously as we get through our addition of fractions today, knowing how to find an equivalent fraction. Obviously, nothing about their fractions look the same. The numerators, or their top numbers, the denominators, we know as their bottom numbers, they're not the same at all. But again, visually, we can see that both cases represent the exact same amount. So let's take a look and see what we did here. Just looking at just the fractions. What we did is when I'm looking at the fraction 1 over 2, and what we did was we changed that bottom number to 8. Anytime we have a fraction where I'm changing the bottom number to something, we have to think about how we changed it. In terms of multiplication, think about what did I multiply that 2 by in order to get to 8. So we know that what number multiplied by 2 will give us 8? Well, that would be 4. I would have to multiply by 4 to get to 8. If it's an easier way for you guys to think that, you can always just take your new numerator, that 8, and divide it by the old numerator, I'm sorry guys, denominator. You could always take your new denominator, which was 8, and divide it by the old denominator, which is 2, and that we know is 4, and so that will show us what we had to multiply by in order to get to that new denominator. So we had to multiply by 4 to get to that new denominator. So what has to happen then when we multiply by 4 on the bottom, we have to do the exact same thing on the top, and that will give us our new numerator now. 1 times 4 we know is 4. And that's how we can do it without having to draw pizzas every single time. We can do that in another example. Let's say I have the fraction 1/2 again, but this time I want to change my denominator, let's say to 12. Let's do another small one here. So we have to think, okay, well, what did I multiply 2 by to get to 12? Those of you guys thinking, we may be thinking, oh, I multiplied by 6. 2 times 6 is what gives me 12. So therefore, if we did the exact same thing at the top, 1 times 6 gives me 6. And you guys may have already done that in your head, as it's pretty easy just to split things in half. We know half of 12 is 6. So therefore, the equivalent fraction for 1/2 out of 12 is 6. But let's say we have the fraction 3/4 again. And this time, I want to eat a pizza that's cut into 8 slices, but I want to eat 3/4 of that pizza. How many slices would I have to eat? So in that scenario, what I'm trying to do is I'm trying to find an equivalent fraction for 3/4, but this time out of 8. So once again, we have to think, what did I multiply down here at the bottom in order to get from 4 to 8? And in order to get from 4 to 8, I had to multiply by 2. So what we're going to have to do is we're going to have to multiply that top number by the same thing. So up here I'm going to multiply by 2. And what is 3 times 2? Well, that gives us 6. So, if we were to draw pizzas on the board here, or on the screen here, if I had a pizza that was cut into 4 slices, this is what's happening here. There's 3/4. We can see that. Taking the exact same size pizza, sorry, very lumpy looking pizza, and cut it into 8 slices. In order for me to consume the same amount of pizza as I did up there at the top, I would have to eat this time 6 slices. And once again, pretending like we have the exact same size pizza on the board here, then we can see this represents the same amount as this up here. 3/4 and 6/8 are the exact same amount of pizza, therefore they are what's called equivalent fractions. Let's practice with a few more. Let's say we have the fraction, how about 4/5? And I want to change that to a fraction that has a denominator of 15, let's say. And you'll notice, guys, that every time I'm changing the denominator from one number to another, it's always a multiple of that original denominator. So, like in this case, 15 is a multiple of 5. So I had to multiply by some whole number in order to get from 5 to 15. And it will always work out that way. I'm not going to change that bottom number from 5 to, say, 14. As we would never do that in any scenario because 14 is not a multiple of 5. And this will make more sense as we get into our addition of fractions here in just a little while. So going and doing what we did just a minute ago, going from 5 to 15, I had to multiply by what number? We multiplied by 3. In order to get from 5 to 15, we had to multiply by 3. So what I'm going to do is I'm going to have to do the exact same thing at the top. And since the top number right now is originally 4, I have to take it and multiply by 3 to get my new numerator. And 4 times 3 gives us 12. And so you'll see as we go through, like I said, as we go through some addition problems, this is going to help us tremendously as we're going to end up having to change fractions in our addition problems, and we're going to have to just change them to an equivalent fraction. So in a later case when I'm having to add the fraction, say, I don't know, let's say 2/3, I'm going to have to change it to something. Let's say I'm trying to add it to a different fraction that has a different denominator, and it has a denominator of, say, I don't know, let's say 18. Then what that means is I'm going to have to change that original fraction to something over 18. And in order to do so, I just have to quickly think, okay, well, what did I multiply by to get from 3 to 18? We multiplied by 6. So therefore, if I just do the same thing up here at the top, also taking it times 6, 2 times 6 gives me 12. So that's the fraction I'm going to use in place of my 2/3 in this problem, because I need to be able to add fractions with the same denominator. We'll get to that here in just a little while. But so far we're looking at equivalent fractions. Another thing we'll be able to do with fractions throughout the class, we want to be able to reduce fractions as well. And what I mean by that, let's go back to our pizzas for just a second. Let's say we order a pizza from, let's say, Papa John's, and I consume half of that pizza again. So instead I had 4/8 of that pizza, right? If I have this, looking at it fractionally, I took those 8 slices and I ate 4 of them. But I always say, if you think about it, when we're walking around full later, regretting our decision to eat 4 out of those 8 slices, I don't walk around saying, oh my gosh, my belly is miserable. I can't believe I had 4/8 of a pizza today. We just don't do that. We don't do that. Instead, we automatically in our minds, we go, oh, I had half of a pizza today and I am so stuffed. Because what we're doing is we're automatically reducing that fraction. I took that off the board here so I could write that fraction again, 4/8, and show you what I mean, that I reduced that in my head from 4/8 to 1/2. So we're kind of doing the opposite of what we did with our equivalent fractions. What reducing shows us, and we'll do that at the end of every operation that we calculate today, you always want to reduce because it just makes more sense to say half instead of 4/8. So we're going down to our lowest equivalent fraction. And how we do that in any fraction, we look at both the numerator and the denominator. So looking at of our original fraction, the 4 and the 8 in this case. And if both the numerator and the denominator can be divided by the same number to get an even number, not an even number, but to get a whole number as our answer, in both cases, both with the numerator and the denominator, then we want to go ahead and do so. And in 4/8, I went ahead and went down to my lowest possible option by automatically saying, yes, I know that both 4 and 8 are both multiples of 4, so in my head, I just went ahead and divided both the numerator and the denominator by 4, and that gave us 1 at the top and 2 down here at the bottom. And so since 1 and 2 cannot be divided any further, since 1, I can't make it any smaller than 1 by dividing. 1 divided by 1 would still give me 1. So since I can't divide that any further, this is what's considered my lowest term, or my reduced fraction here. We could have started with another option. Some people may look at 4/8 and say, oh, you know what, those are both even numbers, so because of that I know I can divide them both by 2. Well, if I do that, that's quite all right, because 4 divided by 2 is 2, right? 8 divided by 2 is 4. So looking at that new fraction now, 2 over 4. 2 and 4, can they be divided by the same number again, giving me a different fraction? Absolutely. Both 2 and 4 are also still even numbers, so therefore I can still continue to divide those by 2. 2 divided by 2 now gives me 1, and 4 divided by 2 gives me 2. So I get the same equivalent fraction that I did earlier, the same reduced fraction as I did earlier, even though I started out with something different, and that's okay. The thing to keep in your mind, though, is, again, if both the numerator and the denominator can be divided by something, and now it has to be the exact same something, then you want to make sure we do so. Let me give you another example. Let's say we have the fraction 10, oh, let me make my marker a little bit bigger. Okay, 10 over 12. Now we have a couple options here. Well, I'm sorry, we do not have a couple options here. We really only have one option. But what I mean by it can be divided by the same thing, for instance, like 10, I know I can divide it by 10, and that will give me 1, correct? Whereas 12 divided by 10 is going to give me 1.2, and that definitely is not going to work then. So we can't use 10 because that means it cannot be divided by the same thing in that case. So we're going to eliminate 10. In the same aspect, 10 can also be divided by 5 because we know that 10 divided by 5 gives me 2. But now 12 divided by 5, no, that also doesn't work because it's going to give me another decimal. So we can't use 5 either. The only option with our fraction 10/12, they're both even. The only option would be to divide them both by 2. And so we do so, and when I do, 10 divided by 2 gives me a whole number 5, and 12 divided by 2 gives me the whole number 6. And 5, 6 cannot be reduced any further, so therefore that is my reduced fraction for this one. So, that's what I mean by that, is they have to be divided by the same thing. Both the numerator and the denominator have to be able to be divided by the same thing. And then if we can, we want to make sure we go ahead and do so. And just like we saw with a couple of them earlier, some have multiple options. So taking the fraction 6 over 24, for instance. 6/24, I can divide both 6 and 24. If I'm going right away to the lowest term, I know I can divide them both by 6. If you can divide both the numerator and the denominator by the numerator, so in this case by 6, then you're automatically going to be in your lowest terms. Since 6 divided by 6 is 1, and I know I'm not going to be able to go any further than 1. And then down at the bottom, 24 divided by 6 is 4, so I'm automatically down to my lowest terms. Maybe we weren't thinking that, and off the top of our head we went, oh, you know what, 6 and 24 are both even, so let's just go ahead and divide them both by 2. Would that work? Absolutely. 6 divided by 2 is 3, 24 divided by 2 is 12. We just now run into another fraction that can be divided again. And when I do so, I look at 3 and 12, now this being my new fraction. And since 3 and 12 I know are both multiples of 3, I'm going to go ahead and divide them both by 3. And that's going to give me the fraction 1. That's 3 divided by 3 at the top. And then down at the bottom, 12 divided by 3 is 4. So once again, I get 1/4. And the last option you could have worked with here is 6 and 24 actually are both multiples of 3 as well. So you could have even started with 3. If we do that, 6 divided by 3, 24 divided by 3, we would have gotten 2 over 8. And then once again, we have something that can be divided one more time. Both 2 and 8 are both multiples of 2. So when I do so, 2 divided by 2 gives me 1. And 8 divided by 2 gives me 4. So as you guys can see, it doesn't matter what you start with, as no matter what, we get our same reduced answer. So, on a homework assignment or on a test, when you're reducing fractions, it doesn't matter. As long as both the numerator and the denominator can both be divided by the same thing, you want to... Oh, sorry. I don't know what I'm doing here. Oh, there we go. You want to, I had a little brain fart there. You want to make sure you do so. So there, I was just trying to get that off the screen. Okay, so that would be reducing. And like I said, we're going to get a ton of practice with reducing, as we will reduce at the end of every single problem that we work with today.